Okay, let's continue. We continue the idea of pricing European claims using a approach, simple in from application viewpoint, not from the proof side, but from application point. We continue to use Gersonov theorem used to price European claims. So let's summarize what we have done last time. Last time we have provided not a honest, rigorous mathematical proof, but the idea of the proof that imagine that we have Black-Scholes model. There we have ST, the share price. We have the T, the bond price. And we have some asset. XT is any asset that can be simulated using some trading strategy. So you combine share and bonds in any tricky way, and obviously when you buy shares and sell bonds according to some tricky strategy, you can create an artificial asset. So you combine them in any arbitrary proportions, and so you have artificial asset that has a price of XTs. And we have real probability that probability P. So that's a real probability in the real world. And the problem with real probability is that processes we are interested in are complex with respect to this probability measure. So these processes ST, BT, and XT are not martingales with respect to real world probability. For BT is B0 times exponent RT, so it's not a martingale. So we decided to do some corrections. So we decided to discount. Okay, if we have a riskless growth rate, we have R, the riskless growth rate. So we decided to, okay, let's discount. So we consider discounted processes, ST divided by exponent RT, BT divided by exponent RT, that obviously gives B0, and XT discounted. So these are prices of share, price of bond, price of some tricky simulated asset. Then we discount them all, and now things are better. That's a constant, hence a martingale. But these two guys, ST and XT, not a martingale. And this guy is not a martingale if we calculate them with respect to P. But then we have a black magic. So we really, for me, it was when I first understood the idea a long time ago, for me, it was like a black magic. You have a real P that works in the real world. you would like to know X0, you would like to know how to price this tricky asset, but the problem is that this process is not a martingale, and hence X0 is not equal to expected value of xt over exponent RT, because that's not a martingale. Yeah, because the process is not a martingale, so the expected value of X changes over time. And hence arrives Gersanov and says, okay, let's invent, let's change not the process. So the first step was to discount. When we discount, we just apply some change to the process itself. And Gersanov said, okay, let's do the black magic. Let's use some P star. We will create this P star in such a way that S0 will be star of discounted share price given F0, and hence, because our strategy is just trading between bonds and shares, we have no third asset. So our strategy, our tricky simulated asset, just works by trading, by buying shares, selling bonds, or by buying bonds, selling shares. Hence, because you have nothing else, X0 is also will be equal to expected value of XT over exponent of RT given F0. And that's a black magic. For me, when I first encountered this idea, for me, it was just a black magic. Okay, we have no identity in real world, so let's artificial measure, but this artificial measure will be used to calculate real life object. So artificial construction is used to calculate something real, because this this X0 is a real object, that a real price of asset X, and this expected value star is calculated using imaginary, so artificial probability, artificial P star. The idea is shocking. You calculate real object, real price, temperature. You calculate the thing that can be in a real world, and you calculate this thing by using artificial probability. That's some kind of black magic for me. When you get used to it, then okay, oh, you just change the method, you apply it. But when I first encountered it, for me, it was like a black magic. You calculate something that is real, that is measurable, that is not artificial object. X0 is not artificial, yeah? That's the price of any asset in Black-Scholes model. But you calculate it using artificial probability, and that's magic. Okay, let's do some more examples.
I have
because that is hard.
Question
yeah.
to the guys also. Like, am I only one who has a bit blurry iPad screen? No, I mean, sorry, tablet screen, yeah.
I can see it as well. Yeah.
So you can see it well, yeah?
It's really blurry.
You can't see the screen.
I mean, it's
kind
visible.
of blurry.
Hard to make out the details.
Mm-hmm. Okay, let's. What can I do? Okay, I can just connect to another server in the VPN. Okay, just let's try. Okay, just a moment. I will. Okay, because it was very clear, visible during the previous lecture. I don't know, maybe it's the time question. Okay, just a few seconds. I will What can I do? Okay, let's just stop. Then let's stop the sharing. Let's stop the